Okay, I'm going to set up a channel in Logworks for oil pressure. This case I chose a Autometer gauge sender, part number 2242. On their website they give you the specifications. It's a 0 to 100 psi gauge sender. So at 0 psi it has 250 ohms of resistance. At 100 psi it has 43 ohms of resistance. We're going to use that to help create a lookup table that we have to use for this type of sender. We have to pick a load resistor. So load resistor feeds the circuit. We have a 5-volt power supply on the SSI-4. We need to create a voltage divider with this resistor and this resistor, the load resistor and the sensor resistance, to create a voltage for the channel to read. With the sensor resistance, the higher the resistance, the higher the voltage will be at the channel. And the higher the pressure, the lower the resistance, the lower the voltage will be on the channel. So that's how this works. But for this to work, we kind of need to know which load resistor we need to use, how many ohms. So kind of two ways to do this. One is you just look at the specs for the resistor. In this case, at 0 it's 250 ohms, at 100 psi it's 43 ohms. That gives you about a 200 ohm difference. So about 100 ohms for the load resistor would work pretty good. According to the Innovate Motorsports documentation, sensitivity on the channel is highest when the resistance of the load resistor is close to the resistance of the circuit, or the sensor resistance. So probably end up with something around 100, 110. I have 110, I have a 100 ohm resistor, so I'll probably use that. That's one way to figure it out. The other way is we can use the thermocalc in this program. Okay, so we're going to right click on the channel we're going to use. We're going to call it the oil pressure channel. So oil P. Oil underscore P. I'm going to make sure it's a external 0 to 5 volt input, and we're going to use the custom lookup table the first time to figure out a load resistor. Thermistor temp sensor, this brings up the thermistocalc program. So we're doing pressure, this is in Fahrenheit, doesn't really matter. I'm going to click on the ohm button, so I'm using ohms and not kilo ohms. 0 to 100 is the gauge range, so that's already good. We're going to leave this on ground because it's connected to ground. We're referencing the positive side, so we're going to connect it to ground. And we have 0, 50, and 100 for our this temperature, but we're going to use pressure. So we're going to bring up this. Okay. So at 0 psi we have 250 ohms. So 0, we're changing this to 250. And at 50 psi we have 111. So 50, 111. And at 100 psi we have 43 ohms. So 43. We want to determine the best load resistor for this range of the scale of the gauge and the resistance involved. So determine best load resistor, comes up with 110. Again, I can use 100 ohm, that's close enough, and it'll be good. So we don't want to create a table right now. That was just to get a load resistor. So like I said, I'm going to use a 100 ohm resistor for this, but now we have to convert that resistance into a voltage for the lookup table to use. So I made myself a little calculator in Google Sheets. This is the voltage out of the voltage divider. The load resistor is going to be 100 ohms, and the sensor resistance we know from that spec sheet. So we're going to start out at 250 at 0 psi, which is 250 ohms. So we're going to enter 250 ohms there. Come on, 250. Comes up at 3.571. So that is our 0 psi voltage. So write that down. Write all this stuff down. Your psi's, your ohms, and then we're going to do another column for voltages. So at 0 psi, 250 ohms, we have 3.571 volts. At 25 psi, we have 158 ohms. Comes out to 3.062 volts. At 50 psi, we have 111 ohms. That gives us 2.630 volts. At 75 psi, we have 75 ohms. That gives us 2.143 volts. And at 100 psi, we have 43 ohms. That gives us 1.503. So now we have our PSI, ohms, and voltage table. We don't need the ohms after this part. Now we have to create a lookup table that just has the PSI readings, and the voltage and their readings. So also on the calculator, I just use what's in the documentation. Voltage out equals voltage supply times resistance sensor divided by the resistance sensor plus the resistance load. And if you look at this this box here, you can see here's the formula which mirrors this. Just it's using cells instead of math formulas. Okay. Go away. So we need to create a text file. I've already done that. It is right here. Called it the 2242 oil pressure sensor lookup table. And in it, so we have, the column requires the unit of measure and the voltage. Each column is separated by a space, and it has to be a text file. So our PSI is 0, 25, 50, 75, and 100. The voltages we calculated were 3.57, 3.062, 2.630, and so on. So this is the text file we're going to use to load the table. We'll close that, and we're going to use a custom lookup table. So right now you can see everything here is in volts. 0.5, 0.5 volt. So we're going to use a custom lookup table. We're going to load from that text file, so we're going to click on Load from File, and here's that text file. I put this one in the LW settings folder because that's where it defaults to. Click on that file, click on Open, and now it has populated the lookup table. We're going to click OK. So now you can see that our unit of measure is PSI. The gauge reading is from 100 and 0. It's equivalent to 0 and 5 volts. And click on OK. It's going to repopulate our oil pressure channel. Now it says oil P, and we've got 0 to 100 psi on the gauge face. So I usually test all my stuff with a potentiometer. So I'm going to start up the log chain. I'm going to connect the port to the log chain, and just by moving the potentiometer I can see the voltage swing. I don't see the voltage involved in that, but according to that table it should be correct. I'll verify it later when it's on the engine stand. And that's it.